This is a little lesson on solving some trigonometric equations. And the first one here is 2 sine x take 1 equals 0. And we have to solve that equation for x, so find x. Now the quickest and easiest way to do it is to use your calculator, if you are allowed to. So in a paper 2 or 3 you are allowed to use your calculator. And what we can do is graph 2 sine x take 1. So we use the graph menu, menu 5, and we put in 2 sine x take 1. There it is. Now we have to check with shift setup whether our calculator is in radians. There it is, angle is in radians, so we don't want it in degrees, we want it in radians. Once it is, press exit, it's okay. Now we can draw this function, so we have to use a proper view window. Let's check the view window. X goes from 8 to 21, not a good idea. Let's first start with the standard view window, negative 10 to 10. And the Y as well, negative 10 to 10. But we can already see the domain here. It's 0 to pi. So I might want to change this from 0 to pi. Shift pi. There it is. We also know that 2 sine x doesn't go higher than 2 or lower than negative 2, but we're taking one away, so the range of this function should well be within negative 10 and 10. Let's draw something. There it is, 2 sine x take 1 from 0 to pi. 3.14 is right here. Where is this function 0? Well, you do g-solve and you find the roots. There it is. So one of the solutions, let's have a good look, is 0.524 radians. And the other solution, use the arrow key, is 2.6179, so in 3 significant figures, 2.62 radians. And for working, we could show that graph and that would give us the points. So all done. But now you have to do it algebraically as well. You need to be able to do that. So how do we do it algebraically? Well, you start with 2 sine x take 1 equals 0. And then we move everything to the right hand side. We unpack for sine x. So the negative 1 goes to the other side and we're going to divide by 2. So that gives us that sine x is 1 over 2, 1/2. So what is the angle when the sine of that angle is 1/2? So we find x by taking the arcsine of 1/2. Now you need to be able to do this without a calculator because these are the well-known angles. The sine of the angle is 1/2 when the angle is pi over 6. That's where it is. But remember the unit circle. So the sine is 1/2, right? 1/2 here. This angle is pi over 6. But there's the other one there as well, with the same sine. And that angle is 5 pi over 6. So the answer is pi over 6 or 5 pi over 6. Now these solutions, they repeat themselves every 2 pi. But since the domain is only from 0 to pi, I'm pretty sure 0's here, pi is here, angle-wise. Yeah? I only need that one and that one there. Pi over 6 and 5 pi over 6 are the answers. So pi over 6 is 0.524 radians, 5 pi over 6 is the same as 2.62 radians. So really easy. A bit more tricky though is this one here, when we have a whole expression and the domain is a lot larger as well, 0 to 6 pi. So let's do this one by hand. I'm not going to do it with technology, because you should know how to do that now. Let's write it up. The root of 2 times the cosine of x, take 3 pi over 4, add 1, needs to be 0 in the domain 0 to 6 pi. Unpack for cosine of the angle. So the plus 1 goes to the other side as a negative 1, and we're going to divide by root 2 as well. So we get the cosine of x, take 3 pi over 4 is negative 1 over root 2. That's a well-known angle as well. When is the cosine negative 1 over root 2? Let's have a look in the unit circle. Negative 1 over root 2 on the horizontal axis, because that's the cosine. So that's there somewhere. 3, well, I don't know. So here it is written negative 1 over root 2. And I'm looking for this angle, but I'm also looking for that angle there. Yeah, so again, there's two answers. Now these angles are 3 pi over 4 and 5 pi over 4, because they're well-known angles. You can look them up in the table for well-known angles. That means this whole angle needs to be 3 pi over 4 or 5 pi over 4. X take 3 pi over 4 equals 3 pi over 4, or x take 3 pi over 4 equals 5 pi over 4. Yeah. These solutions, they repeat themselves every 2 pi. Every time we go around, we come along that solution there. So you can add 2 pi a k number of times. And k is like 0, 1, 2, 3. Yeah. And here as well. 2 pi a k number of times. Because every 2 pi the solution repeats itself. So that's what we call the general solution. Now let's take this one step further. If x take 3 pi over 4 equals 3 pi over 4, then x needs to be 6 pi over 4. The 3 pi over 4 goes to the other side. And every 2 pi, the solution repeats itself. This one here, x is 3 and 5, 8 pi over 4. So that's 4 pi over 2, that's 2 pi. And every 2 pi, it repeats itself. That's called the general solution. Now we need the specific solutions for the domain 0 to 6 pi. So let's look at this first one. X is going to be 6 pi over 4, that's well in the domain. That's good. Then 2 pi along, 2 pi further makes it 8 pi over 4, right? 6 pi over 4 plus 8 pi over 4, that's 14 pi over 4. So there's the next solution, which is still within 0 to 6 pi. The next solution is 8 pi over 4 further along, so that's 22 pi over 4, which is still below 6 pi. And then the next one is 30 pi over 4, but 30 pi over 4 is more than 6 pi, so this is not a solution anymore. Simplify, 3 pi over 2, 7 pi over 2, and 11 pi over 2. This solution here gives us a number of solutions as well. First of all, of course, the solution is that x is 2 pi. But when k is -1, 2 pi, take 2 pi is 0, and 0 is inside the domain as well. So 0 is a solution, 2 pi is a solution, 4 pi is going to be a solution, and 6 pi is going to be a solution. Combining these, x is 0, 3 pi over 2, 2 pi, 7 pi over 2, 4 pi, 11 pi over 2, and 6 pi. So this is the solution to our problem, the specific solution on the domain 0 to 6 pi.